This is a question asked in JEE Advanced 2025 Session 2 based on the projectile motion. The question is, a projectile of mass 200 gram is launched in a viscous medium at an angle 60 degrees with the horizontal. With an initial velocity 270 meter per second, it experiences a viscous drag of minus CV, where the drag coefficient C is equal to 0.1 kg per second, and V bar is instantaneous velocity of a projectile. The projectile hits a vertical wall after 2 seconds. So we have to find the horizontal displacement of the projectile. Let us consider the projectile. The projectile is making an angle 60 degrees with horizontal with an initial velocity 270 meters per second. So let us resolve this velocity into its two rectangular components. One is horizontal component, which is 270 cos 60. Its value is 270 upon 2. (135 meters per second is the horizontal component of velocity. I am not going to calculate the vertical component of velocity since it is not required for us. We are going to find the horizontal distance covered by the projectile in the viscous medium. Here the viscous drag is acting along the horizontal direction and it is opposite to that of the force, which means that the force is opposite to that of velocity. So what they have given is the viscous drag or viscous force is negative of some constant times the velocity. We all know that in accordance with Newton's second law of motion, force is mass times the acceleration, which is minus c times the velocity. From this, acceleration can be written as minus c upon m times the v. This is the acceleration along the horizontal direction. In general, in projectile motion, horizontal acceleration will be 0, but in this case, due to viscous drag, there is a retardation due to viscosity, that is c by m times the v. Negative sign is representing that its velocity is going to reduce gradually. Acceleration can be written as rate of change of velocity. So dv upon dt is equals to minus c by m into v. From this we can write 1 upon v times dv is equals to minus c by m dt. Students, here c and m are constant, so the variable is velocity. Velocity is varying with time. So let us integrate this function to the proper limits. Initial velocity along the horizontal direction is considered to be v naught. I am writing here what is the value of v naught. V naught is equals to 135 meters per second, and after some time t, I am considering initially it is starting from 0 time. After some time t, it is attaining a velocity v, which means its velocity is going to decrease gradually. Integral 1 upon v dv is ln of v to the limits v naught to v is equals to minus c by m. Integral dt can be written as t. So this is ln of v upon v naught is equals to minus c upon m times the t. From this we can write v upon v naught is equals to e to the power minus c by m into t. From this, v is equals to v naught e power minus c by m times the t again. Velocity is the rate of change of displacement, so dx upon dt is equals to v naught e power minus c upon m times the t. In order to get the value of x, we have to integrate this function to the proper limits. Initially the particle is starting from origin, so x component of projectile is changing from 0 to x in a time interval from 0 to t. So integral dx to the limits 0 to x is equals to integral v naught e power minus c by m into t. So x is equals to v naught into integral e power x is e power x. So we can write c power e power minus c by m into t upon, as c by m into t is also variable, we have to write minus c by m in the denominator, and to the limits 0 to t. In the question they have given the time is 2 seconds. So x is equals to v naught along the horizontal direction initially is 270 upon 2 into, let us substitute the values, e to the power minus the value of c is given as 0.1 and m is 200 grams. So we can write 0.1 by 0.2 into t upon minus 0.1 upon 0.2. Now the function x can be written as x is equals to 270 upon 2 into minus of 1 by 2 can be written as 2 e to the power minus 1 by 2 t to the limits 0 to 2. So x is equals to, these 2 get cancels out, minus 270 times e to the power minus 2 by 2 minus e power minus 0 by 2. E power 0 is 1, so we can write x is equals to minus 270 times e to the power minus 1 minus 1. So x is equals to minus 270 into e power minus 1 is 1 by e, so 1 minus e upon e. So x is equals to minus 270 into 1 minus, as per the given data the value of e is 2.7 upon 2.7. 2.7 is 100 times here, so x is equals to minus 100 times 1 minus 2.7 is minus 1.7. So x is equals to minus of minus 1.7 into 100 will be the 170 meters in SI unit. Okay children.